Hello everyone, welcome to the final lecture for week 11. So we have been discussing about modeling long context in the last few lectures, and this lecture will talk about retrieval augmented generation, popularly known as RAG. We already gave you some ideas in this course about RAG, but this lecture will be completely focused on this. So what we will cover today, so first of all, why is there need for retrieval in LLMs? So we will talk about some motivation that why RAG is actually needed. We will talk about some particular models that use retrieval while doing the next token prediction or doing the generation. We will revisit the KNN language model that we talked about in the last lecture in this particular context, that how does this KNN LM connect to the RAG formalism, and we will spend some time on the training details, how is it trained. And so first of all, let's talk about the motivation, right? Why do we need retrieval? So what you are seeing here on the slide are different frameworks for doing question answering. So your task is question answering, right? So how would you do this question answering task? Now in this course itself, we have talked about in many ways, like remember this question answering applications we talk about. So you have a particular query. Now you may want to retrieve information from a large data set, like some external knowledge, Wikipedia and so on. So you may have a retriever. This can be as simple as BM25. You can use dense vectors. Now, given this ranked context, you know the more important passages for this query. Use them in another model, like reader model, that will find out what is the start and end span and to get the answer, right? So this is a retriever reader framework. You are not generating the answer, but once you get this rank context, you can also generate an answer, right? So you can give these context to a model. Like here it may be like a BERT model that can say select spans, but you can use a GPD model, right, that can generate answer. So you can even do a generator, generate answer. This is like retriever generator, and that's very close to what we will call as RAG. Or you can say, okay, why do I need a rank context? Why can't I simply ask a question to the model like GPT and get an answer? Like this is a simple generator. Now, why is this particular view even possible? Because these models have been pre-trained on such a large data. So there is an idea that they have some parametric knowledge. That means through this large training, they have encoded some information in their parameters itself, that given this question, they would be able to use that knowledge and actually answer. Right. So we talked about this zero shot answer generation from GPT-2 that has already been trained on so much data. Given a question, it may be able to retrieve that knowledge and get the answer. Right. It can use that to do tasks for which that particular knowledge is required, because they are nearly trained for every data that is available on the web. So, but the question is then why do we need retrieval? Right? Why do we need to augment them with retrieval? So that's the term retrieval augmented generation. Why do we need that? So there are certain issues with the L language models like that, and that's why retrieval is preferred. For example, this is at a certain screenshot of this model reported in paper in 2023. So what happens? So suppose you ask certain question to the models, and they will give a very nice format, like list 5 important papers authored by Geoffrey Hinton, and it gives a very nice answer. The renowned computer scientist. Here are 5 important papers authored by him, and it gives actually 5 references, and it turns out the first 2 are really the works by Hinton, and this is correct. But then it starts giving you output that are not by Hinton, like deep learning book. So it may have put Hinton as, it may have many references from Hinton's paper, but this is not authored by Hinton, or it's not a paper, right? Paper by Hinton. Hinton is not even an author for this, and then it also lists attention is all you need paper. So while Hinton is not an author for this, right? So these are things that are not correct. And what this paper found out, for example, like in GPT-3 Da Vinci 03. So they say, okay, let's query this for different entities as per their popularity. Like some entities are very popular, means they will be occurring in a lot of instances in the pre-training data, while some may not be so popular, they will occur in very few instances. So what they found, if you this is model without retrieval and this is through retrieval. So if you query for popular entities, the unassisted language model itself gives a very good answer, right. So this has a better accuracy than a RAG model. On the other hand, if you look at the tail entities, that means they don't have so much occurrence. So clearly unassisted language model performs worse than retrieval augmented, right. So retrieval augmented can help in the case of entities that are not so popular in the data, right. So LLMs can't memorize everything like that they have been trained on in their parameters. So they may focus more on the more frequent entities, which it seems to be giving a better accuracy than the RAG model. So so hallucination is one particular issue, especially for tail entities, that they may not have complete memory, but they know the format, so they may actually end up hallucinating. Now this slide gives you some idea about what is hallucination in a brief taxonomy that is presented in this paper. So typically what is a hallucination? So you are getting a response that is not faithful to the facts of the world, right. So nicely, you can have it as a question answer. It's a binary question answer. Is it verifiable? So whatever response, is it verifiable based on the knowledge of the web? So answer may be no. See, if it is not verifiable, you can just call it, you cannot factually verify it. Of course, there may be nuances, like because many times they may invent entity and talk about it. So then you can't even verify this. It may be a subjective statement, unverifiable. So let's not even talk about this part. But suppose if it can be verified from the web of knowledge, then you can ask again questions like, okay, so does it contradict with the evidence? If it doesn't, right, so it may be just entailment, just putting it another way. So then it becomes a factual statement. So that's the only thing that is factual. But if it does contradict, right, then you can go deeper, like is it contradicting the entity level, the entity name itself is wrong, or certain relationship is wrong, or at the sentence level it is wrong. So you can have various kind of categories among these. So yeah, so hallucination is one problem because of which RAG is preferred, because RAG avoids this hallucination problem to a certain degree, right, because even after RAG you still do generation, so you may have hallucination, but at least you have some context to refer to. Right. Similarly, another very important problem why RAG is preferred is that, so all these models typically are pre-trained up to a certain point, right. So like this is another snapshot where the question is, what is this, who is the CEO of Twitter, and the answer is given as per the knowledge cutoff, right. So of certain time, CEO is Jack Dorsey, while if you query Google, you will get the current CEO from 2023, right. So now that means, see, LLM has already learned this knowledge that who is the CEO of Twitter from the web, but that is up to a certain time point. Now you can say I can edit this knowledge, you can do model editing and all, but that's an area of research. You don't have very good methods that can do exactly that update and do not disturb the other models. Now on the other hand, if you use retrieval, you can keep on adding the details to your database, you can keep on updating your data store. That's much more cheaper than training your model from scratch, right. So training model from scratch will be too costly, but your data set can be updated, right, and you can expand it. So that means you can simply have a way in which you can access, given a query, a large database, retrieve information from there, use that to answer your query. That would be much more suitable. So that's another reason why RAG is preferred, because the LLM memory, knowledge is already can easily be outdated, right. It is trained up to a certain point of time only. Then again, when LLM gives output, it's difficult to verify it directly. So it may help if it gives an output along with some citations or references from what sources it has got the output. So that's where again RAG can help, because you can trace the knowledge sources from retrieval ledgers. That I got retrieval ledgers from these websites. So while writing the answer, I can refer, right? I can easily refer like this, or 1 and 2. I can refer the source. I can cite the sources from which I got the answer. So this has become this has been one of the main interesting use case of RAG model, that you can give citations, right? Like here, you want to create an itinerary for exploring Toronto over a span of 2 days. You get an answer from Bing, but I mean, what would help? What actually helps here is that you have various footnotes. So you are linking to various websites from which you are collecting information and providing to the user, right? So this becomes much more interpretable. That yeah, I got this information from this website. You want to know more about it, you can go and see this, right? And gives much more trust in the output of the language models. So then, what is retrieval augmented generation or RAG? So we have a input to a language model, right? So we have a particular task that the language model wants to do. Now, along with that, we want to give it some extra information, right? And for that, we can give a query. We can do a query to a large data store, which can be like trillions of tokens, right? Billions of trillions of tokens. So we can query that, and this will be like simple text documents. They may not be labeled at all, just pages or passages put together, not structured data set or knowledge bases. They can be normal documents. So I can query and get some relevant information and use that to aid the language model, right? Now, so you see the input and query we have put as two different things, because the input to the LM may be different, but what you want to query the index can be decided based on the task. Right? What really do you want to query the index? It need not be the same as the input to the language model, and we will see some scenarios why this is needed. And based on this query, you want to find a small subset of elements from this huge data store that are most similar to the query, right? And you will append that to the language model along with the input and want to get the answer. Now, how do you really do retrieval? So once you have this query, how do you retrieve from this data store? Now, these methods we already discussed while talking about question answering. So open retrieval, right? Question answering. So what is our goal? You want to find a small subset of elements in a data store that are the most relevant to a query. So fine, you have a query and you have set of documents that are stored. You can find similarity based on various methods, like you can do an unsupervised method. You can use TF, IDF, BM25 kind of retrievers to get a similarity score between two pieces of text, and then once you have similarity, you can rank them. So this is one particular idea. You can use TF, IDF, or you can use something that uses the encoder. So you can put query and documents both as encoder, and based on the similarity of these encoders, you can give the similarity of a particular text passage or chunk with the query, right? So you may have query and document encoder, and we talked about Colbert and other kind of architectures. So what is our goal finally? So I want to find a small subset of elements, right? So our task is given a query that is given for the retrieval part. I want to get top k documents from the entire data store based on the similarity, right? Similarity of query and document. How do we find similarity? We talked about two methods, but you can also do it by other things, like you can do fast nearest neighbor search. If they are in the embedding space, you can use some methods by which you can just search through that embedding space. So like there are various popular methods. So FAISS and distributed FAISS scan. There are some very popular methods that you can try and explore. These can be used for finding similarity, right? And we will see at the end there are also some recent methods like OpenAI embeddings. You can use OpenAI embeddings, Contriver, and so on for also doing this retrieval. Now, so retrieval is one part, but then the question is really what do you want to retrieve? So do you want to retrieve the passages? So let's say you have taken all the documents in data store and put them in passages. Would you want to retrieve the passages, or would you want to retrieve the tokens, or would you want to retrieve something else, right? That's the question. And where would you want to use the retrieval? So one thing is you have the input, you want to append the context in the input itself and let the model generate, or you can append even the intermediate layers or at the output layer, right? I mean, you can append at various places. Of course, the most default way is appending here. You have the input, append the data here and let the model do the generation, right? And then the next thing is, when do you want to retrieve? So you are generating, you are doing a generation task, it may be a long text generation task. So when should I retrieve? Should I retrieve only at the input and that's all, or while generating should I retrieve at various points? So this is like, you retrieve only